Advanced Math Ladies, this is lesson 1.5, part 3. Part 2, we ran out of time, and we were working on problem number 23. So let's pick up where we left off there with problem number 23. And we were to an equation that was x squared plus 22x minus 20x minus 440 equals 0. The common factor between the first two is x, which leaves x plus 22. The common factor for the second two is negative 20, which leaves x plus 22. Now our common factor is x plus 22, which leaves x minus 20. So x plus 22 equals 0 when x is negative 22. Since we're dealing with a box, we cannot have a length of negative 22. X minus 20 equals 0, so then x equals 20. If you go back and look at the original picture that I drew you, then the 20 was the width of the original piece of metal, because we used x for it, so 20 inches. And the length of the original piece of metal was x plus 10, so 20 plus 10 would be 30 inches. Ladies, the next problem we need to look at is number 28, which says a rectangle has an area that is numerically twice its perimeter. Its length is twice its width. What are its dimensions? So the area is twice the perimeter. Okay? And if we have a rectangle, it says the length of the rectangle is twice its width. So we'll call the width x and the length is 2x. To get the area of the rectangle, we're going to do length times width, so that's x times 2x, that's the area, equals, let me do this like this, equals 2 times the perimeter, and the perimeter would be that 2x plus this 2x plus this x plus this x. So you'd have 2x plus x plus 2x plus x, which is 6x. Okay, then when you do the math, 2x times x is 2x squared equals 12x. We still need everything on one side, so subtract 12x from both sides. So we have 2x squared minus 12x equals 0. The common factor is 2x, which leaves x minus 6. So 2x equals 0, then x would equal 0 when you divide both sides by 2. X minus 6 equals 0 when x is equal to 6 by adding 6 to both sides. So if we look at our answer, which is what are the dimensions of the rectangle, the 6 was for the width, and the length was 12. So the rectangle is 6 units wide and 12 units long. And you can go back and double check your work if you want to, but for sake of time, I'm not going to on here. Okay, the next problem we need to look at is number 40. So here goes number 40. Which says, if you'll look at that section in the book, it says a projectile is launched from ground level with an initial velocity of v sub 0 feet per second. Neglecting air resistance, its height in feet t seconds after launch is given by the equation s equals negative 16 t squared plus v sub 0 t. And it tells you that the v sub 0 is the initial velocity. t is time, and s is the height. So on number 40, it says find the time that it will take the projectile to reach a height of 80 feet. So in part A, we want to use this equation, negative 16t squared, plus, and our initial velocity on 40 is 128 t, and we want this to equal 80 because s, it tells you, is the height of the projectile at any point after being launched. Well, in order to solve this, we need everything on the left, so let's subtract 80 from both sides. So we have negative 16t squared plus 128t minus 80 equals 0. Well, just like we've done on a couple of other problems, all of these numbers are divisible by 16. So let's divide everything by negative 16 so that we have smaller numbers to work with. So that gives us t squared minus 8t plus 5. You cannot do AC factoring on this because this will not factor to that point. And so I don't run out of room, I'm going to the next page. So on the next page, t squared minus 8t plus 5 equals 0. That means a equals 1, b equals negative 8, and c equals 5. So we're going to have to do the quadratic formula. If you don't remember it, I will write it one time for you. It's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. They will not give you the quadratic formula in college, therefore I think you should know it at this point. The opposite of b is, and instead of x, we have a t, sorry. So t equals, opposite of negative 8 is positive 8, plus or minus the square root of negative 8 squared minus 4 times 1 times 5 all over 2 times 1. If you simplify what's under the radical, you have t equals 8 plus or minus the square root of 44 over 2. Because we're dealing with physics and time and real life matters, we need to use decimal parts. So in this case, square root of 44 is 6.63 divided by 2. So if you do 8 plus 6.63, I'll put plus in a circle, you have 14.63 divided by 2, which is equal to 7.33 seconds. If you use the negative, which means 8 minus 6.63, you get 1.37 divided by 2, which is 0.68. Miss, which answer can I eliminate? And the answer is neither, because when you have a projectile, 80 feet is going to come at two different places. So in this case, those two different places for 80 feet are when t equals 3.33 seconds and when time equals 0.68 seconds. Now part B of the same problem asks us to use the same equation, only this time we want to know when it returns to the ground. You'll remember S is the height above the ground. Well, if I want it to return to the ground, then we're wanting that to equal 0. So let's factor negative 16t out of both sides. Out of both factors, which leaves t minus 8 equals 0. So negative 16t equals 0 when time equals 0. Yes, we know it was on the ground because this is when we started. This is when we threw the projectile. T minus 8 equals 0 tells us that at t equals 8, that's when it returns to the ground. Now let's look at a similar problem, number 41, which has the same instructions and so on. So I'm going to cut through part of the chase. And so we have s equals negative 16t squared plus this time 32t. And we want this to equal 80 for part A. Well, we need everything on one side, so negative 16t squared plus 32t minus 80 equals 0. Everything will divide by 16 again, so divide by negative 16 so that we have smaller numbers. So we have t squared minus 2t plus 5 equals 0. Well, once again, this will not factor to do the traditional factoring, so we have to do the quadratic formula. So t equals the opposite of b, which is a positive 2, plus or minus the square root of b, which is negative 2 squared, minus 4 times a, which is 1, times c, which is 5. All over 2 times a, which is 1. If you look at what's under the radical, whoops, I'm sorry. I'm so sorry about that. Then we have t equals 2 plus or minus the square root of negative 16 over 2. Well, we had a lesson that talked about the discriminant, and if the discriminant was negative, that means you got two complex roots. Well, we can't have complex times in real life situations, so the answer is the projectile never reaches 80. Okay, but now we can still do part B, which says we have negative 16t squared minus 32t, but this time we want to know when it returns to the ground, which would be 0. The common factor is negative 16. So we have t squared plus 2t equals 0. Factor out a t, and that leaves t plus 2. So we set the individual t equal to 0, which says in the beginning, or when we started, or when we threw the projectile, however you want to look at it, that t equals 0. The other time, I'm sorry, babes, just realized I missed a sign. I'm so sorry. This is negative 16t squared plus 32t, which will make this a minus 2t, which will make this a minus 2. Sorry. So now on with our problem. T minus 2 equals 0. So t equals 2. So it started on the ground in the beginning at 0, but then it returns after 2 seconds. I think that will enable you to do all of the problems in lesson 1.5, which is the multiples of 3 through number 48. And then we'll discuss any complications after the holidays. Have a good break. See you then.